Hello everyone and welcome to another AP Computer Science video. This video is going to continue talking about arrays in Java. We're going to focus on passing arrays as parameters or input to methods and returning arrays as values from methods. Because again, for the sake of ease, for readability, creating methods either in classes or static methods that just are available is always a good strategy. And because now we can work with arrays of content, it's a very good idea to get comfortable passing them as parameters so they can become input, or returning them as values so we can send them as output, and combinations of those things. We'll also use maybe different data types as opposed to just ints. So maybe we'll try some doubles and string data types. I'm going to make a new class in our package, array stuff. And I'm going to call it passing. Actually, let's do array methods. So we'll go ahead and make a main using our shortcut. And so the first thing I'm going to do is let's go ahead and make an array just to remind ourselves of how we can do this. I'll do two different arrays, one of them with strings and one of them with numbers. And so for an array, we need to give it the data type, because only one type can remain inside of an array at a time. The brackets, so that we recognize that it is an array and not a single value. A variable name, and then when we initialize it, we must use the new keyword along with the data type and how many spots there are, the size of the array, because we are also required to define the size of an array when it's created. So here we go. Well, that's if we decide to make one dynamically. If we decide to make one literally, then we can just literally pass it in. So for the string one, we'll make it literally. So I'll say string array, and I'll call it names, and I'll do a literal array, which is curly braces, and then the values of the appropriate type in comma separated. So for this, it's going to be string, so I'll put some literal strings. I'll say Jimbo, and maybe right? And so there it is. And then of course we need our semicolon at the very end. So that's a literal array with 4 spots in it, and this is calculated behind the scenes. It can establish this from the literal values, and then there are 4 string values. Let's make a dynamically constructed array, and we'll go ahead and put Boolean values. So we'll say Boolean array with the brackets, and we'll say lights. We'll just call it lights. And we'll say it's new, with our keyword new, to construct the object. Our type is Boolean. It is an array, and let's go ahead and say that we have 10 slots. And so I have 10 spots. By default, a array of primitive Boolean values defaults to false for each spot. And so what I want to do is I want to randomly assign a true or false to each spot instead of leaving it all false. I could just pick a random one myself in it, but it wouldn't really be random if I'm picking them. So let's make a loop that goes through every spot, and then there's a 50-50 chance that it's true or false. And so we have to establish how to do that possibility. First, to visit every spot, we need to use a loop. Maybe a for loop would be reasonable. And we'll say go from some starting number to an end number, and we know what a good number would be. One, because we've chosen the size of our array ourselves, but we can also use that length method from the array. So let's go ahead and try something like, we're at I equal to 0, I less than lights.length. Remember, length is a property of arrays, not a method, so there are no parentheses, unlike strings. And let's go ahead and say go up by 1 each time. So I++, there's our body, or our loop setup. And now what I want to do is I want to say, okay, well, 50% chance that it is true and 50% chance that it's false. So let's go, or as close to that as we can. So why don't we just make a random number between 0 and 1, and if it's below 0.5, then it's true, and if it's above 0.5, it's false. And that way we have a relatively even chance of either one. So we can just do, we could make a variable and all that stuff, or we can just do it in one line. Since by default math.random returns a number between 0 and 1 not inclusive, we can say if math.random is less than 0.5, then we can say lights. And now here's the part where we have to access the array. Lights is the entire array, so I can't just say equals because that would try to assign a single Boolean to an array, and that doesn't make sense. So you got to remember that array is like that accordion folder. You can't put one value in the entire folder. The folder has a bunch of slots. You must choose a spot in order to assign it a value. So we're going to use the bracket notation to fill it in, and we must give it a number. So I'm saying if we're looping through 0 to length, and I represents that value, we should say lights at I, so whatever that number is, 0, 1, 2, and so on, and assign it a true value. Otherwise, we must want to assign it a false value. Now, it is false by default, but I'm going to assign it anyway just in case, so that we're guaranteed or confident that we always have an assigned value in our array. So at the end of this array, we have some combination of Booleans, and that's a convenient thing to do. So let's go ahead and try making a method that does something with this array. So I'm going to work with the Boolean array first before I work with the string array, just to make things a little bit easier. And so what I want to do is I want to make a method that accepts a Boolean array of lights, right? These true or falses, and returns true when all of them are true. So if every light is on, then we return true. If any of the lights is off, then we say the whole thing is false. So this is a pretty easy thing to do if we know our Boolean logic. But first, the real challenge is making the actual signature for our method. We start off with our access modifier, public because we want to be able to use it. We're going to use static because we're using it in main. There is no context. There is no object that's going to be calling this method. It's just a loose method, so static. The return type is Boolean because we want a yes or no answer about whether a light, all the lights are on or not. And then we have to give it a name, so let's call it all on. And then now here's the new part. Our input is not a single Boolean. It is not a single int or a single double. It is an array of Boolean values. And so thankfully, this is the same premise as any variable declaration, any parameter declaration. When you make a parameter, it's type and then variable name. Now the type is Boolean array. So I'm going to say Boolean brackets. And then we should give it a name. And again, the name is just the variable name temporary for the parameter. So it's not that important what it's called. It should have a good name, but it's not some program breaking situation if you do a name that's kind of easy or small. But I'll call it lights again. And now maybe I shouldn't call it lights just because that would maybe imply that they have to be the same, and that's not at all true. So I'll call this one LGTS, right? So almost lights, but without the vowels and the H's. And so now what I have to do is implement this to make sure it returns a Boolean. And so what is the purpose we're going to do? Again, typically when you're given a parameter, you have to do something with it. It's helpful information. Here, the parameter is a collection of Boolean values. And I said we want to say they're all on if every single one is on. So if all of them are true, then it's true. If any of them are false, the whole thing is false. And so think for a moment, and what logical operators do we know that mimic that behavior? If all the things in the logical operator are true, it's true, and if any of them are false, the whole thing is false. So if you've thought about it, the answer should be the AND operator. When you AND two logical or Boolean expressions, the result is false if any of them are false. So let's go ahead and do that. Now what we could do is we could loop through and check if it's false, then return false, or we could just AND them all together. So there's more than one way to do it. I'll do it maybe both ways. It's kind of arbitrary, but let's go ahead and say Boolean on is equal to true. We'll assume that it's true by default, and we'll say for int I equal to 0, I less than LGTS.length. And remember, it can't be lights because that was declared in the scope of the main, so the only variable that's a Boolean array is LGTS. Now we're going to go ahead and say I++. We're going one spot at a time, and all we have to do in my example is say on and is equal to on and LGTS at I. So if this was true, it's true and whatever the next thing is. If this was true, then the whole thing is true and we reassign it. If this happens to be false, the whole thing is false, and then we know every other time it's going to be false. And again, this is not necessarily the most efficient solution because this will go through all the lights no matter what. And in reality, we should be able to do it in a much quicker fashion. Right? This is one potential solution. So I'll also say we can just simply say, instead of doing this, we could say This is one possibility. Actually, I'll leave it like this for now, and we'll just go ahead and return our value on. And if any of them were false, the whole thing would be false. So this is one solution. What I'll do is I'll comment this out temporarily and show a second solution. And in fact, I don't need this one either, so let's do that. So that was one solution. Another solution could be this, almost the same thing, but we don't really need the Boolean variable. We could just say, well, int I equal to 0, I less than LGTS dot length, same as before, I plus plus. So the loop is the same, but we could simply ask a simple question, and we could say if LGTS at I is false. This is one way of writing it. I could have also said not equal to true, or I could have just said not this thing, because the negation would have right associativity. We would retrieve the value, and then we would do the negation. And now, so we have to point out something. The bracket notation in the levels of precedence is more important than the Boolean operators. It has to be evaluated before we could do the logic, so it does have a higher precedence. But this is acceptable, and if it's false, then we simply return false. As soon as we see one that's not on, then not all of them are on, so we can say return false. And then we could also just say return true. Because if we manage to get to the entire, if we manage to get to the entire loop without finding a false, that means we saw all the lights on, and therefore all lights are on. So either one of these is an acceptable solution. It really is not important which one you pick. And there might be other ways of doing it. We could probably shorten it a little bit if we thought about it carefully. So we accept a Boolean array, and then we return a single Boolean value. It's just one small example. And we could, of course, test this. We could always go ahead and do printing out. We could say system.out, and let's print out lights on, and we would say attach to all on, and then the input is the array, which is called lights. You give it the entire array, not a single spot, but the entire array, and now we can run our file, and we should see. Now, realistically, we're probably going to see false most of the time, because a 50-50 chance, like a coin flip. What are the chances that they're all true? Each has a 50% chance, so the multiplication of all those things is very, very small. It's 50% 10 times. So 50% times 50%, or 0.5 times 0.5 times 0.5. 0.5 to the 10, which is a pretty small number. So let's make it smaller. Let's make it so it's much more possible. Let's just do 2. And in this case, there would only be 4 possibilities. False and false, true and false, false and true and true. So there's a 1 in 4 chance that we see it true. And let's see. Let's hopefully let it happen. False. Right. I mean, it's not. There's no guarantee we'll find it. And so let's make it even easier. Let's do an array of size 1, and now there's a 50-50 chance. So we should hopefully see a true pretty quickly. And there it is. So the first one was true. Now let's see if the first light is off. Maybe true again. Let's see if we can get it to be false. And there it is. Right, so the idea is the same, of course. With a higher percentage or higher number of spots, it's much more difficult to find maybe the answer we wanted. But there it is. Right. So let's try another method. And this method, our goal is going to be to return a new array of values, right? Because we can make arrays whenever we want, not just in the main, but in any method, and we can return them. The only difference is our return type has to be adjusted appropriately. So I'm going to go ahead and shrink this one a bit, and let's go ahead and try writing another method. And so we were given a literal array of strings, or any array of strings. Why don't we make a new array with only the first letter lowercase from each string that was in the original array? So for example, our method would say, take the J from Jimbo and put it lowercase, and that's the first spot. Take the T from Timmy, lowercase it, and put it in the second spot. And then take the H from Herbert, put lower h, and put it in the third spot. Take the J from Janet and put it at the bottom in the fourth spot. So let's make that method. So let's go public. We want people to use it. Static, because there is no object that's going to be controlling it. And now here's the new part. In order to return an array, we must have a return type that matches. There's not anything really new. I just want to confirm in our minds that if arrays are valid data types, then they can be used as a return type. So I'm saying we are going to return not a single string, but an array of strings. Right? And so an array of strings is the return type, and that's a pretty big order to fulfill, but it's not going to be that hard to do. Our name will be called getFirsts. but our input is also an array of strings. So string bracket, and then we give it a name, so we'll just call it STRs. We don't know what they are, it doesn't really matter to us, and we can fill it in. So in order to return an array of strings, we must have an array of strings. Remember, often when you make a method that has a return type, you tend to make a variable that's going to be the answer, and then you send it back with the return statement. So in this case, that's also true, but with an array of strings. So string array, and I'll call it firsts, and I'll initialize it immediately. Now here's the question: how many spots should this array have? Because we must know the number of spots in order to create it. So give yourself a moment, think about it. How many spots should this have? And if you don't have an exact number because you can't figure it out, is there a value or code that we could write that would give us the number of spots where we wouldn't necessarily know the exact number? So if you give yourself some time to think about this, we can say, well, if we know the length of the given array, we can use that as the value for the number of spots in the new array. So we're going to say new string array, and it is going to be what size? And since we don't have an exact number, we're going to say, well, it's the length of the given array. So strs.length, which is a number, and you notice it is an integer. And so if this was 5, then now this one has 5 spots. If this one had 20 spots, this one now has 20 spots. So now we have a new empty array. Now what I'll say is arrays of class types, strings or class types by default, don't have values except the null keyword. But null is dangerous and you can't refer to null. So if we tried to do something like that, we would cause a crash. So this method assumes that every single spot in this array of strings was filled with a valid string. If it was not, it would cause a problem. Even an empty string is a valid string. It just cannot be null. It must be a string. And so let's go ahead. And so the solution here is pretty simple. We're going to look at every single string in the given array, retrieve its first character, make it a string, lowercase it, and put it in the new array. So our loop will loop through the original array STRs. So for int I equal to 0, I less than strs.length, I plus plus. Again, we start at 0 because it's the first index. We go up 2, but not including the length, so that we're staying in bounds. We go up one spot each time. And so now we don't have to do any questioning. We know that they're strings. Let's simply rip the first character off. Well, actually, we do have one danger if it's an empty string, so we should maybe ask that. So let's ask that. We'll say if STRs, and now STRs is the entire array. Bracket notation will let us pick a single string. And so I'm going to say at spot I, so the first time it's the 0th one, then the first, and then the second, and so on. Now this thing here is a string. So I can actually use dot notation to call a method. And if that's not comfortable for you, then what we can do is we can temporarily make a variable. We can say string str. Well, let's call it word, and we'll say it is equal to that string. And now we can say word dot substring. Oh, sorry, we want to see if it's empty. So we want to say if word dot length. Well, there's multiple ways to ask if it's empty. If word dot length is 0, if word dot equals an empty string. So if that's true, then we simply want to store an empty string. So we'll say firsts equals first at I equals an empty string. And there it is, right? Otherwise, it has at least one character, so we can take that first character. So we can say firsts at I is equal to word dot substring 0 to 1, because we know there's at least one character because it's not empty, and then dot to lowercase. Right? But we do need to protect ourselves, because if you said word substring 0 to 1 on an empty string, you would get a crash because that would not be a valid index. Right? There is no index 0 in an empty string. And so once we have this now, what can we do? We can return the array that we filled. Right? So we can say return. And it's not a single value, it's the entire array, which is firsts. And there it is. And so now we can test this, but in order to test it, we need to see what's inside of the arrays. And so we should maybe make a method that prints an array of strings. This is a convenient way to make another method. So let's quickly make a method that prints out all the strings in an array. And we'll say it's void because we want to print the content. Print array, and we'll say it only takes an array of strings, and we'll call it ARR for array. And now let's go ahead and say, you know what? For every single spot in the array, again, notice how I'm kind of just moving along because hopefully you see the pattern is very similar for most of these solutions. If you're using an array, you're very likely to loop through every single spot, and so these are pretty much a very similar situation. Now, again, there are many situations to do other things, going backwards, going by even numbers, going to odd indices. I mean, there's a never-ending supply of possibilities. But if you're just going through every spot from beginning to end, the loops tend to be exactly the same. So we're going to print out a value, but I want to put them next to each other nicely. So I'm going to get rid of the ln. We're going to print whatever the string is, so ARR at I, and we'll attach a comma to it if they're not the last spot. So let's ask a question. We can say, you know what? If I is not, or if I is less than ARR.length minus 1. So if we're not the last spot, right? And strictly less than means we're before the last spot, then we can do this with the comma. And if we're just the last spot, then what we're going to do is we're just going to simply print it out, but not put the comma. This is not the only way to do this, but this is one way to do this. And that's it. Notice there's no return because it's a void method. And again, the reality is arrays are just other objects to be manipulated in our code, and so they can be parameters, they can be return types, they can be anything we can imagine. So now, given that this I think works properly, let's test this out. The first test right away will be very simple. Why don't we print out right here with print array the value. So we're going to say print array, is that what I called it? Yes. And we're going to print out names. So hopefully we'll see Jimbo, comma, Timmy, comma, Herbert, comma, Janet. Let's see what happens. And there it is. Now, of course, I forgot the ln at the very end, so let's fix that. Let's do one last print here because these were prints, not print lns, and so that means the last thing that's printed ends up being jammed next to it. So now if we run it, there we go. So it seems to work on at least on this first array. Let's test it on the one that we build with our method. So now what we're going to do is we're going to say, let's get our answers, and we'll make it equal to. And so what I'm going to do is I'm going to call the method get first, and it returns an array of strings. So if I'm going to store the answer that's returned from a method somewhere, the variable has to match the data type. So string array is what we're doing. And so we can say get first. And what is the input to get first? An array of strings. The only array of strings we have is names, so we'll pass in names. Now this itself is an array, so let's go ahead and print it out. We wrote our print method, which is fantastic. So print array answers. And now let's see what happens. I claim if we did it correctly, this one will show Jimbo, Timmy, Herbert, Janet. This one will show J, T, H, J, comma separated with all lowercase. So let's see what happens. And there it is. And notice that last comma is not there because we were logically verifying that we didn't need that last comma. That's pretty good. Right? There's a lot of functionality we can do, quite a bit. It takes a little bit of practice to get comfortable with this thing. We'll try some more complicated situations, and you will do some coding bets that will make you think about edge cases. Right? I was always safe starting at the beginning, going to the end. But maybe you start at the end and go to the beginning. Or maybe you start in the middle and go only to the right. Or maybe you start at the beginning and only go halfway. Or you go by even indices. I mean, there's all kinds of combinations that you could do. Or maybe comparing single values from one spot in the array to other spots in the array. And so this can get very complex very quickly, but the idea is that if we're paying attention carefully, we can get away with quite a bit of work with just some loops and the array property length and knowing how to assign or retrieve values. Right? So this is quite a bit of interesting work that we can do. So the video will stop here, and next time we'll continue with some more examples because this definitely is a huge part of the AP exam. Right? There's a joke that goes around that says basically the AP exam is just a test on loops. It's AP for loops, right? Because if you can use for loops, you can do most of the work that's asked of you. It's a huge part of programming is iteration, and so it's definitely good practice to do this. And arrays are a huge part of this too. So the better we are at this, the better off we'll be. So I'll see you in the next video.